Good afternoon. I'm Bernhard, co-founder and CEO of Wealthport, and this is Noah, principal data scientist. We are happy to be here and talk about automated data curation at scale. In case you have questions, at the end of the presentation, there's enough time for discussion. Gartner and Forrester have recently declared data preparation, an area of data curation, as a hot topic. We are going to show you why it's a hot topic and what kind of solutions are out there in order to tackle data preparation challenges. Data preparation today takes a lot of time. Whereas data scientists talk about themselves, it takes up to 80% of their time preparing data. And that's a lot of time. Shouldn't they be doing 80% of their time extracting data instead of preparing data? Data preparation always or most often involves IT. So it's not a self-serving activity. And quite often the interaction with IT are sometimes faster, sometimes they take more time. If you want to mine a lot of different data sets, then traditional approaches don't really scale over 25 different data sets. And last but not least, when you're processing all the data, when you're transforming all the data, then the data origins are normally lost. And it's actually very important to know at any time during your analytics where the data came from. So what kind of options do we have today to prepare data? There's always the option of doing it manually. But however, people are error prone, it's expensive, and actually it doesn't scale. If you have twice the amount of the data, it means you need twice the amount of the people. Second option is rule-based, and I'm sure that most of you people are familiar with these kind of tools, the so-called ETL tools, extract, transform, load. These are deterministic systems, and you need to set up all the rules to capture all the different cases, and it takes a lot of time also to maintain it, which is at the end also expensive. And in order to use an ETL tool, actually it's kind of complicated, and I'm sure you need an IT guy. So the last option, probabilistic approaches. They are based on statistics, natural language processing, and machine learning. Here it's more the case about selecting, identifying, and combining the right algorithms, which at the end do the job for you. But you have to keep in mind when using statistics, the results can be approximate. So let's have a look at the normal data integration process. It all starts with the identification of the source. You need to see what's out there, you need to see if it's available, who has access to it. Unfortunately, it's not as easy as just shopping data in a shop. Then you want to have a close look at the data, you profile the data, you look at the metadata, you have a look at the quality of the data, how many values are missing. And then you normally realize more often than not that the data is in a bad condition that you expected. So you need to clean it. You need to detect outliers, you need to detect or complete missing values, and just normalize also the data. This means correct some spellings, some formatting, some different units, or some classifications. Then the next step is the identification of the join, or what kind of relationships are between the data sets, what are the overlapping parts. And here, if you have still noise in your data, it makes it difficult actually to make this join. If there's no primary key, then it often requires a fuzzy matching. When you finally put them together, you need to do the entity resolution, you need to find which records belongs to each other, and at the end, you need to deduplicate all the records. This is also quite a computational intensive problem, and then if you have a lot of manual feedbacks here, it takes a lot of time. You're almost through. At the end, it's just post-processing before you can do the analytics. This means just aggregating, doing a grouping or filtering on the data. And then the data is ready to be integrated or to be analyzed. On the right side, you see our view on the automation potential. We think that identify the joins, normalizing the data, and doing the entity resolution, there are methods out there where you can automate this a lot. And now Noah is going to show you how you can do this.
Thank you, Bernhard, for the kind introduction. Welcome, everyone. So we are going to talk about some of the methods that are around for all these processes that Bernhard just introduced. Of course, this is not an exhaustive list of possibilities of methods that you have and algorithms, but they will involve outlier detection, type detection, encoding fixing, entity resolutions, and many more. So the first step is that we want to profile data, and in this example we are looking at how can we do a probabilistic scheme detection. So how can we find actually out what is in the data source? The first part is, for example, the first method that I'm going to introduce is that you can compare the data that you have in one column to data that you have in a so-called authoritative table. This means this is a table of known facts, and you have already kind of classified it. So in this example here, you have, for example, the last names, and you have a list of all the last names, be it just in German or be it all around the world, and then you can see R is the sample from the column, does it correspond to this kind of authoritative table. Next thing we're going to do, especially with numerical data, but we can also, of course also do it with other data as well, is to create a histogram and see what is the distribution of your values. And for example, if you have Boolean values, then the histogram is usually like that you have two big amounts of true and false values, but maybe some of the users, when they put in the data, they put a 1 instead of a true or a yes, and then we can detect these outliers, and then that helps them later for normalizing. Then next thing is also that we want to find out maybe what kind of types that you actually have in your column. Do you have strings? Do you have all capital strings? Do you have formatted numbers like phone numbers or dates? And for that we use these decision trees. And of course it's not as simple as that. Usually you use, for example, a naive Bayes tree that you model that you have already trained beforehand with machine learning. Then the next step, once you have kind of analyzed and found out what is actually in your data, you want to clean it, normalize it, and in case of missing data, you may be even able to impute some data. So the first example is something that you kind of encounter quite often here in Europe. These are these encoding errors that the umlaut and the aigus and all these things are messed up because some background library is just working with ASCII characters. And then of course that's quite trivial to once fix these. But there are more problems. One thing is, I already explained to you that we are using these authoritative tables to kind of figure out what kind of data we are dealing with. But for example, especially when you think about countries, then there are different ways of naming these countries. You have the ISO 2 and 3 codes, you have the standard name from in English or from the national language. And then we can maybe use these, and once we figured out that they are all countries, that we can normalize it on one column and say, yeah, we put here just the ISO 2 codes. Then it's afterwards, once the data scientists are doing their analysis, that they can nicely group their data. Also, when we do the histogram analysis, we can, as I said, you see some outliers. And especially if you swap columns, which can often happen, especially with first and last name, that the user puts in the wrong sequence, that you can detect these outliers and see within one row, oh, they should be swapped, and then you swap them. Also, a third possibility or fourth possibility is pattern mining. When you say forget the country, but you see often that when you have Winterthur, that means also that the country is Switzerland. Then you can find this pattern that if city is Winterthur, that implies that the country is Switzerland. And by that you fill up or impute the data into the country column. Then the next step, once you have the single data sources cleaned, you want to bring them together, and you maybe want to bring together more than just one, but hundreds, thousands. And then it becomes very quickly very tedious to identify the proper joint columns, especially when the data sources are from various random sources. The first approach that you can do is just simply look at the attribute names, but usually, especially when they are from different sources, they don't match up. Here, for example, you surely want to match this source with this source on the client ID, but here it's called CID, and here it's called client ID. And these names don't match. So what's the next step you're going to do? You are going to look into the data itself. And here again, you want to have some algorithms that detect that you have, for example, here some suffixes that are just some assurance numbers, that like a hash number to make sure that the number is put in correctly. Or here you have some prefixes that internally identify the column. And then you want to first strip away these prefixes and suffixes, and then you create the histogram of it, of these columns, and then you can compare the histograms and see whether they are from the same distribution or not. And you see, for example, that here the product ID has much smaller numbers and the distribution is shifted to the left, while for these two the histogram is matching. Then the next step is that usually when you put together different data sources, it can be that you start to accumulate duplicates. Let's say you are a company and you bought a competitor, but they have already one of your clients in their databases, and you want to bring them together, and suddenly you have the same client twice in your database. Then you have to somehow figure out that they're the same and then deduplicate them. For this, we are using a similarity measure, and in a naive approach, you are just calculating together the similarities of each field, and you compare that. And that means if you describe it as a weighted sum, the weights are all the same. But then usually a column like whether you have a premium abonnement or whether what's your last and first name have different information content, and they're not so good in differentiating the two entities. So the next thing you want to do is, especially after you clean the data and actually normalize the data, make actually different entities much better comparable. You want to use machine learning techniques to adapt the weights so that you are able to give to the first and last name more weight, while for example, this Boolean value here has much lesser weight. Yes. And basically, you use then the machine learning to incorporate the knowledge of the user, the semantic knowledge that he has about the table. And in the background, the algorithm still do not know about anything what's actually in the column. And then the next thing is that you also want to initialize these weights with an intelligent guess, because as I already said, you can kind of see from the distributions of, that means the histogram of your values in the columns, which columns may have more information content while others have less. And by pre-initializing these weights with these clever guesses, you can also save on the training iterations. Because let's say you have 1 million records and you may need to look at 1,000 records for each iteration, and it may take you an average 30 seconds to decide whether two entities are duplicate or not. I mean, they can be very similar, and then you have it quickly done, but maybe you have to check in some other databases. That already means that you would use for 3 iterations like 3 days. And you need these 3 iterations to actually come up with weights which are very similar to the pre-estimated ones. So by that, we have much better out-of-the-box accuracy, and this may even eliminate the need for training at all. I mean, if your data is quite easy in some sense, not so diverse, and you don't really care too much about accuracy, you may be already fine with this. It depends really on the data source. Then a little bit more technical. When you do the similarity calculations, there are different approaches how you can actually tackle this problem. So let's say you have here the matrix with all the similarities considered. So this is the entities, and here the entities, and you compare always pairwise. Of course, the first clever approach is to just calculate the upper right part of the matrix because the other is symmetric. But then next thing you want to do is the data, because this one still runs proportional to n squared half. But when you cluster the data in advance, you only need to calculate basically the area in these little triangles. And this doesn't only save you on the computational time that you need, but also we already hear that these days CPU is not so much a problem. What is really a problem is the memory bottleneck. If you have several nodes on your cloud and you have to send around all the time your data, this drags you really down. But when you are able to use these similarity calculations within one of these clusters, just on one node, you save a lot of memory shuffling around. And thus, speaking actually of infrastructure, it's quite important. We heard already today that Apache Spark is quite important for that. I think this is currently one of the state-of-the-art infrastructure. There are still some things that need to be figured out, but I think this is really the future to go. And I don't know whether all of you already heard about Mapreduce. This is really what Spark is all about, and you can kind of think about it in a way that you are applying a certain operation in parallel on different nodes, and then you reduce the result in the sense that you're shuffling around the data. So if you think about making sandwiches, you map the operation of cutting the bread, tomatoes, and the cheese. You map them on all three of them, and then you do it in one go, and then you do the reduce operation, which means you shuffle around the cheese and the tomato and the bread, and you get nice sandwiches. And as a guy who's hacking on it, I can really say it's nice that it is programmed in Scala, because this is a very nice language. It's functional, it's object-oriented, so it has all the goods from both sides. And Spark has really nice libraries. We already heard about the MLlib and also some graph libraries for the graph algorithms, and also some streaming libraries. So I'll hand back over to Bernhard.
Thank you. So let me quickly summarize what we have seen today. So the first takeaway is that these probabilistic methods actually help you to do a lot of your job. But when you're using these methods to save time, you have to find the right balance. So you have to keep in mind that the probabilistic approach is using approximate results. And in case you need 100% precision, then you are might better off with a deterministic system. But also with a deterministic system, you can always introduce errors. So think about it twice when you want to use it. The second takeaway is that machine learning increases the accuracy and the precision of your system even more. As we have seen in the deduplication example, you can save easily a couple of days of work. And when you use these two systems together, you actually realize that you can mine much a broader data set than before. You can also rely on higher quality data, which means at the end of the day, you can extract deeper insights and more knowledge out of your data. So at Wealthport, we are developing software in the area of data curation, and we're using these algorithms to make the life of a data scientist easier. If you have a question about Wealthport, please approach us in the coffee break, or go on our website, follow us on Twitter, Facebook, or just come to the inaugural meetup of the Apache Spark, which takes place on the 23rd of June here in Zurich. Thank you.
Thanks for the very interesting talk. Spark session number 2. Afterwards we'll have Spark session number 3. Any questions to our speakers? Start here.
Very simple questions. Who are your customers?
Well, basically everybody who's doing analytics, who is dealing with data and who needs to prepare the data, is a potential customer for us. we are focusing on some areas, and our areas are master data integration. So all the customers who are dealing with, is it product or customer records? It's just bringing together different kind of customer data, different kind of product data. Then we do the data integration, we do the data cleaning, and at the end they have the curated data sets to work on.
Maybe a technical question. How do you actually fix encoding errors? Umlauts, etc. How do you do this?
There are actually libraries out there that do that for you.
So in Computating went through several stages already, the code has really been lost.
Sorry?
Don't do any statistics on, say, okay, this is probably a name Müller or so.
Yeah.
Is that the encoding really got lost? Is it 5 or 7 times? Like, common fixes?
That the information is lost? Or?
Yeah.
I mean, yeah, if the data is too messed up, then there's no chance to fix it. But like, yeah, you can't put too much information back into it. I mean, but for some cases, you can really nicely map it back and forth.
We would have time for one more question.
Yes.
Oh no. Okay.
Could you give examples of machine learning algorithm you're using for the identification part?
Yeah, this is naive bias as well. Do you have a question as well?
I mean, when you have so much data, how do you figure out if you made mistakes with it? Do you have any good approaches for sort of screening to make sure you haven't joined the wrong columns together or matched the wrong things?
There's of course a chance for the user to give back feedback, right? So that he sees what is coming out, and if he sees there's some non-matching, or if the scoring is not high enough that of the algorithm that decided to bring together two columns, then of course the user is asked. Yeah. Yeah.
Okay, I would say let's thank our speakers again.